Hello, my name is Jack Montoya, and this is Physics 2212, Lab 2. For our second lab, this is a revisit of our charge tapes from Lab 1. This time, the purpose is to compare the point charge model to a line of charges model. A line of charges means that the tape will be broken into infinitely small segments treated as point charges. Then, using GlowScript, we will validate the calculations and simulate the interactive forces on the tape. A sneak peek at the results of this lab is that the net charge from the point charge from lab 1 was 1.2 e to the negative 8 coulombs. The new net charge from this new line of charges model was 2.5 e to the negative 8 coulombs, which is more than 2 times greater than the net charge from lab 1. This experiment, we will assume air resistance is negligible. The tape is now a line of charges, and both tapes are equal in charge. Additionally, we will need to understand three fundamental equations. Newton's second law tells that the net force on an object is equal to that object's change in momentum over time. The force of gravity is equal to the mass of an object times the acceleration due to gravity. And lastly, the electric force between two charges is proportional to the product of the charges and inversely proportional to the distance between them squared. Here is the experimental data that was obtained during Lab 1. These measurements will be used in calculations for this lab, as well as constants for our GlowScript model. Now let's quickly recap the results of Lab 1. The charge of the U-tape was positive 1.2 e to the negative 8 coulombs. There were 7.5 e to the 10 deficient electrons, and the ratio of deficient electrons to atoms was 1.88 e to the 7. Here are the results from Lab 2. The electric force on the tape was equal to the gravitational force, allowing the tape to be in equilibrium, and this force was calculated at 2.1 e to the negative 3 newtons. The charge of the U-tape was found to be positive 2.5 e to the negative 8 coulombs. Now I'm going to present the GlowScript model in sections to help convey the important aspects of this computation. This first part in lines 39 through 45 is a function to calculate the electric field. After this, in lines 54 through 70, is the function that creates our line of charges. This is probably the most important takeaway of this lab. Mathematically, we typically iterate across significantly small pieces using integrals. However, in GlowScript, we can accomplish this using a for loop, as shown starting on line 64. Here, we will again use for loops to iterate. This section of the code calculates the electric field at each segment of point charges. Using this electric field, the electric force is also calculated by multiplying the charge of each segment. Here is the model produced by our GlowScript code. The forces on tape B are displayed. The green arrows indicate the individual electric forces from each small segment of the line of charges model. Notice that these green vectors sum to the net electric force depicted by the white vector. Some possible errors associated with this lab include incorrect measurements during Lab 1 for physical quantities such as length or mass. Also, our assumption that both tapes have equal charge may not be true in reality. For our what-if question, in Lab 1, we did treat each tape as if they were individual point charges. We got the charge was positive 1.2 e to the negative 8 coulombs. In Lab 2, we treated the tape as a distribution of charges with a net charge of positive 2.5 e to the negative 8 coulombs. This charge from Lab 2 was significantly more than in Lab 1, showing a difference in calculation. Now why? These models differ because Lab 2 breaks into small segments, which better reflects what is actually happening inside the physical tape. Therefore, this answer is likely more accurate. Thank you for watching.